Hi everybody and welcome back. This is going to be problem number 3 on homework 7.3 and some people were asking about this one, so I figure I'll give you a little bit of help here. So, alright, so we have this, it's not really a very realistic scenario, but I guess you could conceivably do this, where if you have a shopping cart and a cereal box stuck to the front of it, and the cart is accelerating so rapidly, so fast, that it is applying a force to the box. You might say a normal force to the box, right? Because it's at right angles to the face of the box right there. That creates enough friction, static friction, to counteract the box's tendency to slide down. That is because of gravity. All right, so the box wants to slide down because of gravity, but it doesn't because there's enough friction between the box and the cart holding it up right there. So the question is, what is the acceleration? Where is it right here? Find the acceleration. What's the acceleration required to create such and such a normal force so as to create such and such a friction force as to balance out the weight force of the box right here? All right, so I'm going to draw my box in, we'll say orange here, because we'll say it's going to be a Wheaties box. All right. And there's my box just like that. And so it's got the downward weight force, mg, and it's counteracted by the upward, I'll draw this in brown, we'll say upward static friction force, all right? And we call it the static friction force because the assumption is, assume what? Box does not move, right? So it's not sliding down. So therefore, we can say that the acceleration of the box, at least in the y direction, is 0. So we can say the net force, I'll change a different color, the net force on the box in the y direction equals 0, right? Because it's not accelerating downwards. But we can say the net force in the y direction can be summed up as static friction force acting upwards and the gravity or the weight force acting downwards. Both of these statements being true, we can then say that static friction force, oops, sorry, I'm jumping ahead of myself here. Static friction force minus mg equals 0, and therefore we can say that has to equal mg. All right? So I think you probably could have seen that coming, that's got to be equal to that. All right, so what is that static friction force made up of here? What I'm going to do is I'm going to kind of see if I can move some of these things around, and it looks like I can't, so that's all right. Well, static friction force is the coefficient of static friction times the normal force, right? And then we're going to set that equal to mg right there. And so we'll say the normal force equals mg over the static friction coefficient. All right, we're going to dotted line box that, because we've got a statement now about what the normal force needs to be in order to create enough friction force to hold up the weight of the box. All right. But we can also make statements about the box in the x direction. All right, so I'll draw this kind of over here. All right. Well, let's look at the box right here. What is the only force acting on the box in the x direction? The only force. That is the normal force. The force between it and the cart. No other force is acting on it. The normal force is helping to accelerate it forward, of course, but it's also helping to create that friction as well. But the net force on the box is that normal force and nothing else. That is in the x direction. Well, what else is true about net force in the box in the x direction? Well, it equals ma, right? So we have, we can say that the normal force equals ma. We have a statement for the normal force over here that we solved from finding out what it has to be in order to create the friction force in the y direction. And so now we can tie these two together. All right, that mg over mu s has to equal mass times acceleration. We're solving for acceleration, right? And the question is, does the mass of the cereal box matter? And the answer is no, that does not, because you're going to see that the mass will cancel out. I'll let you take it from here. This is how we set this up, but we find basically the link between the horizontal and the vertical is the normal force. So we state it in terms of horizontal, or in vertical, state it in terms of horizontal, tie them together, and solve for our acceleration. Hope that helped. Let me know if it doesn't. I'll see you on the next one.